Yes, we're live again, and it's SDN Cast 127 with today a guest, Carlos Landeras from
Hello.
Madrid. And your hosts are Fanny Reinders and Maarten van Stam. Well, we were a bit over time, but we had some issues again.
Rather over time than never. Hey, good evening, Carlos. How are you?
Hello. Thank you very much for inviting me. I'm very good. My name is Carlos. As Martin says, I'm from Madrid. I'm a Spanish guy, and I'm very happy to be with you tonight.
It's actually past your siesta, I believe. So isn't that...
I missed my siesta today. That's a very good thing.
Almost dinner time, I think, in Madrid at this time.
Yeah.
Having late dinners.
Yeah, I used to have a late dinner, so it's not a problem for me. Yeah.
So what we're going to be doing something different on the show today. I believe, Martin, depending on the time we have, normally we do like live coding, not live coding, like events and news and stuff. But always when we have guests, we tend to give more time for the guests. So if there's time over, then we'll dive into the...
Today. Yeah, we have a lot of code today, so...
Yes.
Yeah.
If there is time, we will dive into the news and stuff. But I think Martin, what do you think? It's like let's just cross over and maybe Carlos, tell us a bit more about yourself, who you are, and before you start demo.
Okay, I'm a 33 years guy. I'm a software developer. I have been for the last 11 years. All this time I have been working with Microsoft technologies and .NET Core, but maybe for the last 3 years I have been contributing hardly to the community and in different .NET groups. I really like the new change, of course, that Microsoft did, that I am very committed with this new .NET Core technology and all the new stack that Microsoft is offering. And last year, I was awarded the MVP Professional Award. That's why I'm going to meet you this year, Fanny, because the last year I didn't see you around there. But I hope we can meet this year.
So it will be your second MVP summit.
Yeah.
And it's last year was your first MVP award, right?
Yeah, the last year I was awarded the MVP 3 days before the summit, and I could go.
That's cool.
Because I was at New York at that time, and it was like a miracle because I have the reaction time, you know?
Okay, now looking forward to meeting you.
It's the same.
What do you do? Like, what's your company's, like, what does your company do? And, what technology stack, etc. are you like building, for instance?
Yeah, my enterprise is called Plain Concepts. We are an enterprise with several offices all around the world. We have offices at Madrid, Sevilla, Barcelona, Seattle, London. Now we have opened a new office at the Netherlands. Okay, so we are very happy. And well, we are focusing a very wide variety of technologies. We are doing things with artificial intelligence, blockchain, augmented reality, virtual reality, cloud, web development, and a very big portfolio. We are now like 9 MVPs on the enterprise. And I really love working here because the people is very committed with their work. There are people with brilliant mind here. And even the highest people, on direction, some of them, they are very talented technical guys. That is something very strange nowadays.
What's your location in the Netherlands?
I don't know yet because we have just arrived there, and I don't know the office location. I know it's very close to the airport, and it's in a co-working where Microsoft is as well. And I'm not really sure what the street or the zone is, but I will tell you when I know.
Well, we'll find out.
Yeah.
Okay, and I believe my thing is muted. I believe your company's name is it Xabaril? How do you spell it? Or is it not?
It's Plain Concepts.
It's Plain Concepts. And what is Xabaril? Is that like a organization name for your GitHub stuff, or because BeatPulse?
Yeah, Xabaril is a group of coding people that was created by one of our technical leads. He's like the he's like the lead of technical leads. He's called Unai Zorrilla. He was the maximum Entity Framework 6 contributor, being a non-Microsoft employee, who was the guy who ported the most code to that repository, and he created that Xabaril team. We have several repositories there, and one of them is the repository we're going to be talking today, because when Microsoft announced the ASP.NET Core version 2.2, they pointed to the developers that it would be a nice option to use our health checks packages.
Okay, so the BeatPulse is actually an extension to the ASP.NET health checks thing, which is health checks are built into ASP.NET 2.2, right?
Yeah,
and
if you want, I can maybe share my screen.
Yeah, I think we can just jump into the demos and just maybe explain, because people think, well, health checks, blah. But what does BeatPulse bring to the table that's the wow factor? So maybe you can just take over from here and just...
Yeah. The BeatPulse project, can I share the screen?
Yes.
Yeah. Do you know how to share the screen in Google?
Yeah, of course.
Okay.
I'm on it. Let me 1 minute. Screen. Sure.
Your
It's
company
okay.
will be in Hoofddorp.
Yeah.
And the Kruisweg.
Can you see the screen right now?
Yes.
Okay, great. As Fanny said, the Xabaril is like a jabalí in Spanish, you know, this pig with horns is our logo, and we have several repositories here. And the BeatPulse was an initiative that was created by Unai Zorrilla, okay? And it pretended to be an ASP.NET Core health checks library. It's a full health checks library. It has all the functionality inside. As you can see, we have several packages to check the health of the typical enterprise services. A lot of databases like MongoDB, SQL Server, MySQL, DocumentDB, a lot of Azure services as well, message brokers like Kafka, RabbitMQ, Identity Server. It also has a UI interface to show the health of all these services. But then, after this library was going to be extensively used, Microsoft announced the new ASP.NET health checks, the new ASP.NET version 2.2 that was rolling out their own health checks library. They tried to have the health checks library in the past. An old repository existed, but it was discontinued. And right now, they made this announcement. Here, this is the website on the ASP.NET blog. They announced the 2.2 version, and one of the most important things, it was the health checks. So we were very happy because they announced that they were going to have integration with BeatPulse, and this is a message that was written by the authors, by us. And what we did, if you can see this repository, is making an advertisement that this BeatPulse project was going to be maintained for bug fixes, but that we were migrating to the new ASP.NET Core Diagnostics Health Checks repository. That is the one that is extending the Microsoft Health Checks interfaces and mechanisms. Right. All right. And if you go, for example, to one of the demos that Microsoft to the tutorials, that Microsoft is offering, that they actually show you how can you work with this new feature. They mentioned this BeatPulse repository several times and for different demos. And that's because Microsoft gave us the chance to create health checks, our own health checks, but they do not provide health checks from the different enterprise services that are available nowadays.
So that's where BeatPulse comes in. Then.
Exactly. They bring into the play one health check for Entity Framework, that is this one. But apart from this, I think there aren't more health checks available. So here's where we were talking with them, and we decided to migrate all our health checks. Here you have the current list. You can actually test all these services. As you can see, you can check URIs, URI groups, several Azure services, several network services like SMTP, IMAP, TCP, DNS.
So I can have a health check for my service bus.
Exactly. You can definitely come. These are all the Nugget packages that are available. And we have as well migrated some of the most interesting features like the UI. And we have also, maybe interesting for the people running with containerized applications, we have also this UI Kubernetes automatic discovery that can discover for the UI your deployments if you set some tags to the services that are exposing that deployments.
So wait, it will magically then know these services?
Exactly. Internally, this service, the Kubernetes Automatic Discovery Service, is talking with the Kubernetes API and trying to discover all the deployments that are tagged with the health checks label, and they will automatically show up on the interface.
Okay.
So the demo that I have for today is showing to the listeners that are with us right now how this new health checks API works, making a demo from scratch. And it would be interesting as well, maybe configuring this UI. It's intuitive for developers, so they can see how their applications are performing. We also have webhooks, okay, that will be triggered, for example, to this Teams channel. And if we have time, we have also publishers. That means that all our health checks can be published to different monitoring systems like Application Insights, Prometheus, and all that kind of stuff.
Okay, just before we move on, just to set the scene of what health checks are.
Yeah.
Just to explain, because when people think about health checks, at least me initially when I saw health checks, I thought it was just an endpoint where you invoke it and the health check was done at that moment. But it's not just that; it's just reporting the health at the stage. So a health check is actually happening all the way at the background all the time, and when you connect to this health check endpoint, it's just merely reporting the latest health, right?
For example, it depends. For example, in BeatPulse, we have a strategy that our UI is calling to different endpoints to gather that information automatically. But it's actually when you invoke one of the paths of these endpoints when you are going to test the health of the application, so the performance of your application that is using health checks is not affected. Okay, and the last part of the demo for today that I think is the most interesting, as you might know, Kubernetes offers as the liveness and readiness proofs. And it's very interesting because actually with this health checks library that the ASP.NET team provides us, we can take advantage of these features and have our containerized applications always healthy, or try to always have the applications running in a good shape.
Okay, that's great.
Okay, so if you want, maybe I can start.
Yes, please be my guest.
Okay, I'm going to create a new application on Visual Studio.
So you're showing us from scratch how to set up BeatPulse.
Yeah, absolutely. Okay, I'm going to create a new ASP.NET Core application called Web App.
And this is a silly question. This is .NET standard based, so I can have my full framework.
Yeah, no, the ASP.NET Core health checks are for ASP.NET Core, sadly.
Okay. Only for .NET Core.
Yeah, and only for 2.2.
Oh yes, right, because it's extending.
Exactly.
2.2. All right, yes.
Okay.
Silly me.
Yeah. So the first thing I'm going to do is leaving the Docker support enabled, because one of the things that I'm going to be doing today is building the Docker image of the code that we are going to be doing. And for to be fast, I'm going to disable the HTTPS, so I don't have to be configuring the certificates on my Docker image. Okay.
Right.
This would be the starting from scratch application. I'm going to delete everything. And the first thing that I'm going to do is I'm a console guy, and I'm going to go to this health checks directory where our web app is located. Okay, here is our CS project. Okay, and the first thing that we have to do to start working with health checks is installing a NuGet package that is from Microsoft that is called Microsoft ASP.NET Core Diagnostics, because this belongs to the diagnostic interface health checks. Okay. I always try to install the NuGet packages from the console because it's blazing fast compared to the Visual Studio Windows. Okay, so during the demo, I will be using it extensively. Okay. The first thing that we have to do to use the health checks is just adding the health checks services to the service collection. Okay, so the service provider will be providing these services to the dependencies that will require them later. And the first thing that we can do is just declare a health check. That's why I say that Microsoft provides us the mechanism to create our own health checks. For example, a very simple health check would be creating a class, my health check, that inherits from eHealth check. That is the interface that this library provides us. And the only thing that we have to do right now is returning a health check result. So imagine in this health check, you're going to do several checks, for example, and whenever you think the checks are ready, you can return a health check result that you can choose between degraded, that might mean that our system is not down, but some of the dependencies are degraded, healthy status, or unhealthy. Okay, so this would be, for example, the shape of a health check. I don't know, sorry, from result. Okay, this would be the shape of a health check, and you could just register in using the typed add check method by using my health check and giving it a name. For example, my check. Okay.
Yeah.
This is very easy. With that, you have one health check in place. For the purpose of this demo, I'm going to use another approach that is just using a Lambda function to register a check. You are provided with a cancellation token right here, okay? And you can just return as well the health check result. So for example, the first parameter of the check should be a name. In this case, this check is going to represent the actual container or application health. And I am just going to return the health check result healthy. Okay, but this is only registering health checks inside the dependency injection or into the service collection. Okay, we have to actually expose this, like Fanny said, very well said before. You have to register the middleware, the use health checks, and you have to select a path where you want your health checks to be consumed. For example, right now I'm going to use /health, and we have to configure the health check options that are very interesting because they are going to allow different approaches. Let me import this class. Okay, and the health checks options have 4 options right now. The first one is allowing caching responses. That this might be that if a client is requesting the help from this endpoint too often, we allow the middleware to cache the response. It is always disabled. Okay, and if you want to have the real estate from health checks, I don't use to enable it. And we have a predicate. The predicate, okay, it's a function that gets invoked by the middleware, where every one of your registrations, for example, this is a registration, and every check that we are adding is a registration, will be tested to get the predicate. So for this simple demo, I'm going to say that all the health checks are going to be shown under this path. Okay. So if I trigger this demo, it's going to be very easy to see the output of this self-health check, because this is still a very simple demo. It will get more difficult later. I can see the healthy string. Okay, Microsoft decided that the response writer, I'm going to show you what the response writer is something that we can configure. Okay, is this parameter on the health check option. The response writer is a function that receives the HTTP context and the health check report. So you can write to the output stream on ASP.NET Core whatever you want. The default implementation from Microsoft here is very simple. Let me check it. Where I have it.
Yeah, so it hands you the HTTP context, so basically you can do whatever.
Exactly. Their default, as you can see, their default response writer is called write minimal plain text, and it will only return the content type text plain and give us the string of the status. Okay. This is also in companion of a response with the status code. So if I call, for example, localhost health with a verbose mode, I can see, I don't know if I stop it. Okay, but I can see that, for example, if the global output of this endpoint is healthy, I will receive a 200 status code okay. And if some of the dependencies are not in a good shape, I will receive a status code 503 service unavailable. But that's something that we can actually configure for the endpoint. For example, if we want to say that, hey, instead of having a service unavailable, for my unhealthy, I want a 500, okay? So this is something that can be configured. For this demo, I'm just going to use the standard status codes, but this is something that you can tweak.
That was an interesting syntax you did there with the block brackets.
Yeah, it's a fast way to initialize a dictionary.
Okay, well, it's the first time I've seen that. Is this like C# 7 point blah or
7 maybe, yeah, 7.0.
Okay.
Not sure, but I think it is the new dictionary initialization.
Cool.
If you see that receives a dictionary of health status and an int that will represent the status code. Okay, so let's go into something more interesting. We're actually going to try to test some of the most typical enterprise services. For example, I'm going for SQL Server and Redis cache that are two typical dependencies on our ASP.NET web applications. And for that, I'm just going to install two of the BeatPulse packages. I'm going to type .NET add package ASP.NETCore, that these are our namespaces, health checks, SQL Server. Okay. And I am going to install as well the Redis package.
Just to ask a question quickly, the initial diagnostic you added in the code, this one, is that, or the self one, is that actually checking the health check endpoint itself, or is it actually checking, what is it checking?
Right now, it is checking everything, because my health check on the predicate have true. I could have made something like this, okay, and it would only check the self. Okay, and that's something that we are going to do later when we are doing the Kubernetes liveness and readiness proofs, because it's very interesting separating the health checks for the liveness and the readiness proofs. But right now, because I want to show you different things, I'm going to show everything. So that means with the predicate true, all the registrations of the health checks are going to be shown under this endpoint. Okay, so right now, as our health checks are on the Microsoft Extensions Dependency Injection namespace, we can directly add the check without having to import anything. And I'm going to configure a connection string for SQL Server. This SQL Server doesn't even exist yet. I'm going to configure it later with Docker. Okay. So I'm trying to make a test to the initial catalog database the master catalog. I'm going to configure a user ID that is going to be SA for testing purposes. And my password is going to be, for example, password slash, password exclamation. Okay, that would be one health check against, for example, one dependency of this application that might be this connection string. And we are going to add another one that is Redis.
So underlyingly, what is that SQL thing is doing? Is it just executing like a select star one whatever query?
Yeah, exactly.
So
internally, exactly. Yeah. It is making a dummy query, but actually you can specify on a non-required parameter your query.
I see.
Okay, this is making a default select one that will try to connect with SQL Server. The connection is successful. Try to this dummy query, but you could actually query one of your tables. Okay, and you can as well configure other other parameters are the health, the failure status that you want to configure if you don't want, for example, unhealthy, and the tags that we are going to see that later because the tags are really useful. Okay, yes. So yeah, we used to have our health checks with very parameterized options, so people can perform different checks. Okay, so right now, for example, I have these three health checks in place, and right now I'm going to very fast create these Docker services. Okay, I'm going to create a Docker file, a Docker Compose file to configure two services. These two services are going to be the first one, SQL Server. Okay, we are going to use the Linux container because it's very lightweight. The image is called Microsoft MSQL Server Linux. This image to work needs you to set two environment variables that is accept EULA. That means that you accept the software conditions, and there is a password that is going to match the password that I configured here on the health check. Okay. And in the last step that we have to do is registering the ports that we are going to be sharing with the host with my actual machine because the application needs to connect. Okay, so we are going to use the default one, and that would be a SQL Server in place. And the same for Redis. We're going to configure a Redis with the Redis image, and we are going to use the default port that, if I'm not wrong, is C3796379. Okay, so these services are up and running, and if I do right now Docker Compose app detach it, whoops, nothing is wrong. Environment, nothing is wrong. Let me check. Service SQL Server, environment, and ports. Accept EULA. I don't know why this is failing.
What was the problem? I didn't see exactly.
The problem is, let me check. Docker Compose invalid. Config option for SQL Server environment unsupported. Why?
Environment.
Oh, yeah, exactly. Yes. Environment.
Typo.
Yeah.
Typo. Sometimes when being a bit of English helps, I suppose.
Yeah. Yeah. Okay, so these two services are up and running, and if we launch again our application, it should be healthy. Okay. The Microsoft actual response writer is useful whenever you are maybe just requiring the status codes for these services, but not when you want to get an extensive information. We have one container broken. Let me check why. The Redis image is crashed. Let me check why. I don't know why this is crashed, but it crashed. Actually, oh, it's the SQL Server. Sorry. Let me check why.
These things happen. Don't worry about it.
Yeah.
What this show is all about: real programmers having real problems sometimes. You know.
Exactly.
Every week, so.
Okay, it seems that we didn't accept the EULA correctly. Let's check.
Accept it automatically. Yeah.
Let's check why I wrote accepta instead of accept. Exactly. So my fault. I'm going to compose again the container, and that should be running. Exactly. It is running right now. As you can see, we receive an unhealthy state, and right now, F5, we are in a healthy way, okay? And as I was telling you, this is useful, for example, for Kubernetes, because we just need the status codes, but if we want to work with NOI, for example, we need to use another response writer, okay? So we are going to install another package from the Xabaril repository with .NET add package, and this package is called ASP.NET Health Checks UI client. Okay, this response writer is going to be designed to offer richer information. So if you just write here UI response writer and import the namespace, we offer here the write response health check UI response method that would be similar to the Microsoft, but instead of being returning a text plain response, it's going to give us a full JSON information that you're going to see right now. Okay. Here you have it.
Yeah.
Right now, you have the global health status of this endpoint with the total duration of the health checks and the individual execution duration of each of the health checks. Okay. So if right now I make a Docker stop, Docker compose stop Redis, and I put Redis out of play, if I refresh here, my global status is unhealthy, and we can see the actual exception that the health check is providing, that there's no connection is available to service. Okay, so we are getting a little bit more of information, and as a developer, you can write your own response writer to adapt it to your necessities.
Is there a kind of standard, like giving us RFC diagnostics response in, like the problem details, they've got an RFC format. Yeah. Does health checks also have something like that?
No, the only implementation that they have out of the box is this one, because I was in contact with Reno Wag, for example, from Microsoft, and he told us that they think this is something that has to be implemented by developers, and it shouldn't be provided by the library. But it's true that unified response could be maybe good for DevOps processes, but well, it's okay. You can just cook your response writer very, very fast.
Yeah, I see it more like the structure needs to be sort of a community standard where the structure of a health check means it's these fields at least.
Yeah, but they decided that this response writer could be up to the developer, so they just offer this one.
Yeah,
before going to Kubernetes, I'm going to fastly create another project. Okay, because I want you to see that you can actually consume this response writer, and I'm going to create a health checks UI. Okay.
Okay.
This health checks UI is going to be a separated project that is going to be in charge of monitoring the output of this application. But this doesn't mean that we can have more than one. Okay. So if I go to this health checks UI, I install another package, and this is the only one that we are going to need, this ASP.NET health checks UI. Sorry, add package. We can start configuring the UI. We also have on the repository this package as a Docker image, so it's very straightforward to have the UI up and running without the need of creating an ASP.NET project. Okay. So the only thing that you need to do here is adding the services to the service collection and registering the middleware that is called use health checks UI. And it has a setup. This setup is optional, but I like to put my UI path on this path. The default path is called health checks UI. Okay? Just to be simple, the UI path.
Is it possible, because I've tried this, is it possible to have your path as a root?
At the root, no, it's not, because it will probably collide with MVC. So we encourage. I think if you try
even
to do it, if the own MVC framework will complain.
Yeah, but even though if you have a project without MVC.
No, if you have a project without MVC, I think you definitely can. You can.
Okay.
I think that's a very good question, because we have created the library, but I actually never tried to put it on the road because it's like it's well known that the developers will have on the root the important thing that is the application, but I have to try it. Okay, I have for demo purpose I have created a file, so we don't have to write from scratch. That is the AP application settings. Okay. For this UI, and I'm going to describe what this application settings means. You can configure this with environment variables if you are working with Docker, but if you want to configure it with the APP settings, you can create a health checks UI section in which you can configure an array of health checks. Okay, so for example, I'm going to call this fancy health check application that we have created the webcast API. And I'm going to change the path to health UI because it makes sense to call it that way because it's returning an UI format response writer. Okay. So having this in place, our UI is going to be monitoring this API, and we have configured one webhook against Teams that is going to send messages when our liveness is down and when our liveness has been restored as well. And we can configure the evaluation time in seconds between the different checks. And the last thing that I have to do is configuring this application in another port, like this one, okay? And not using Docker right now as the execution, but Kestrel, because I'm going to execute both at the same time. And this health checks UI project is going to be monitoring the web app. Let me do it.
So to be clear, what is the scenarios for this dashboard thing? You would probably create this on a separate project that's just purely for dashboard purposes.
Yeah, you can actually do it in a separate project, or you can do it on the same project. For example, on our repository, we have both samples, the integrated UI on the same place or separated. But I wanted to show you that it can be an external dependency, even a Docker image, okay? And we can do it. Let me check. Something is not good. Localhost. I put it on. What's going on?
501.
Oops. Let me check if I change. I think I changed exactly. I changed it on the wrong place. Sorry. This is the initial application, and the new application is the one that is going to be 5001.
Yeah.
Okay. Let me execute it again. And this is the endpoint that is serving the health, and this is the one with the UI. Okay.
Right. Yeah.
You can see you can change the interval here, and whenever the response from the health checks is ready, it will appear here. Okay, as you can see, we have here the webcast API, and our Redis service is down. We have received, as you can see, on our Teams webhook that is useful for developers, telling that with the webcast API down and that there is at least one health check failing. All right. So if we put back again the Redis, everything should be fine. Where is the Docker Compose? I think it's here. Yes. Docker Compose start Redis.
So I can basically, with these webhooks, I can, instead of doing a Teams or Slack message, I can do a post to Event Grid, for instance.
Yeah, you could post wherever you want. You just configure where you're going to receive that payload. Okay, as you can see, for example, Redis is healthy now. Okay, because I started Redis again. All our API is healthy. We can actually add all the APIs and services that we want here. Okay, and we should have received the webcast API is restored and is back to work. You can configure the message, the format, if you want images, what the message is going to be. We just require you to put this liveness, that is the definition of the liveness, okay? And we will call the different payloads, or we will call to the webhook with the different payloads, depending on the health of the service.
Cool.
Okay, so this might be something that you can actually do with the new ASP.NET health checks, but there are, at least for me, more interesting scenarios that is, as Martin told me before, it seems that Kubernetes is mainstream right now. Everybody is talking about Kubernetes, and we can actually benefit from this new library when we are working within a container orchestrator. Okay, imagine, Fanny, I'm going to put you in a scenario I want you to think. Imagine that inside this application, we are going to have two flags, very simple, two flags that are going to represent our global health application, okay?
All right.
Imagine that this flag represents, for example, in an enterprise application, that the application is responding on one controller and is not hung, and that you have to do some checks to to be sure that the application is up and running. We are going to represent it with a flag for demo purposes, okay? And we're going to introduce a new bool that, for example, might be a third service. Imagine you said Azure service VAS. I'm going to call service VAS health, okay? And you should be wondering, why are you declaring service VAS health, okay? I'm going to deploy this application to Kubernetes, and if I put down SQL Server or Redis, all of the replicas are going to be affected by that. But by simulating the service VAS health with a flag, it's going to allow me to just put down one of the dependencies in one of the containers, okay? For example, if I do apt check, and this is going to be service VAS, and instead of actually calling service VAS, I'm just going to simulate that we are making that check, okay? So I'm going to do this, service VAS healthy. I'm going to return the health check result healthy, and otherwise, I'm going to say that the health check result is not healthy, okay? I don't know if you're following me, the idea. I just need an external, I need to simulate that one of the three dependencies is broken, and I want to do it by hand, so you can see how Kubernetes, okay? And we're going to do the same with the application, okay? Because Kubernetes on the liveness checks, the only thing he cares about is about the own container health. And I'm going to do exactly the same, okay? Right now is where the different API features enters, because, for example, the self-check, that is the one that is giving us the application check, is going to be referenced by name, but these three services, we are going to tag them with the, we can create a string array to tag our services, and I'm going to tag them like services, okay? We could also use the name dependencies, okay? But this tag is going to be used to group the services that our application requires to be working. Okay? So the SQL Server is going to be in the tag services, Redis as well, and the service bus as well. And we can leave this health check in place for our fancy UI, but actually we can create another one that is going to be self, that, as you might be wondering right now, is going to be the endpoint that the Kubernetes liveness proof is going to be querying. Okay? So here, the only thing that we have to do, as we did before, is say, hey, I want only my registration with the name self to be reported here. If you think about the Kubernetes liveness proof, we don't need an advanced response here. We just need the status code. If the status code of the check isn't healthy, Kubernetes will know, because it's not a successful status code, and it will trigger all the things that we are configuring.
So the liveness probe for Kubernetes, is that always /self, or how does that work?
Oh, you can, when we see the Kubernetes deployment file, we are going to dissect that part. You can actually choose the path that you want.
Check.
Okay. And our readiness proof is going to be in /ready, okay? And the health check options for these are going to be, I only want the registered health checks that are inside the tags. For example, tag contains services. So only my services will be reported at this point. And to finish this, we just need two pieces, okay? That is the ability for us to make the demo to swap these two flags that will change if our application is healthy, and to change if our dependencies or dependent services are healthy, okay? So let's configure very fast two endpoints. One is going to be called switch, okay? And this one is a middleware, a mapping that is going to allow us to change the status of our application. We're going to say here app healthy is the opposite of the current status. All right, and let's write to the output stream some information to let us know what's the current health state of the container. I'm going to make a string interpolation here, saying, for example, environment machine name, because as you might know, this machine name is going to be the pod or the container host name that Kubernetes creates for us. I'm going to say machine name health status, change it to app healthy. Okay. And I'm going to do exactly the same to switch our dependency that is simulating your beloved service bus. Okay. I'm going to put switch services or service or switch service bus or whatever. And I'm going to put here that if service bus health is the opposite of the current one. And on the message, we're going to put maybe service bus health, change it to service bus health. You have any question or any doubt? Are you following me, the idea of what I'm trying to do?
Yes, absolutely.
Yeah.
Great. Then we only need one last piece. That would be, for example, having a terminal middleware. That is the one that is going to be executed when no other path is matched. That is actually the echo or the hello world of our container. We're going to write response, write async, and maybe something like hello from environment machine name. Okay. This would be everything. We have to do one last change that I used to forget, but not this time, thankfully, that is changing the connection strings. But as you know, this local host connection strings won't work in Kubernetes because this would be the container itself. And SQL Server and Redis will be external dependencies in other containers. So let's give it names, for example, SQL Server. And Redis will have the Redis name. Okay. So what we are going to do right now, before going to Kubernetes, is build the Docker image. The Docker build web. We're going to call the image web app in this context, and we are going to use the Docker file that actually Visual Studio created for us, and I missed the file parameter. And our Docker image for our web app application is actually being built. Okay. Do you find this interesting, funny, Martin?
Yes, absolutely.
Yeah.
Okay. So where did you? You did not show us that Docker Compose file yet. So
the Docker which Docker Compose?
Because you're going to be running Docker Compose up.
No, I actually am going to run a Kubernetes deployment file, and I'm going to show you right now. As you can see,
I'm running Kubernetes, not Docker Compose. Sorry.
Yeah, exactly. For example, for this demo, I am using.
Yeah, that's what I meant. Where is that deployment file? Because obviously the SQL name and the Redis name is in there, right?
Yeah, I'm going to show you right now. First of all, I have to stop these services because these services might collide with the infrastructure that I'm going to configure with Kubernetes. So I have to search for the Docker Compose file and put it down. So my SQL Server and Redis ports are released. Okay, so let's go right now to the interesting part of the Kubernetes deployment files. I have here one infrastructure YAML file that, as you can see, has configured the same that we made before with Docker. It's going to create a deployment with one replica for SQL Server. It's doing the same that we made with Docker, configuring the container with the same password. We're going to expose this deployment with a cluster IP, so it's going to be available inside the Kubernetes. And we are also deploying Redis as infrastructure with another cluster IP that we available on the same port. Okay, but this is just the services. The interesting part is the deployment itself. Okay, let's review again what we did. Okay, we have the self-health of the application that we have simulated with this flag that might be different checks, and we have these services. These two services are real. But if we put one of them down, all the ready checks is going to be unhealthy. So we added one fake dependency that is called service bus that we can actually switch by using the switch service endpoint. Okay, so remember this /self and /ready because these are going to be our liveness proofs. Okay. Here I have the deployment YAML that is going to be called the web app deploy, and we are going to start with 3 replicas. That means that we are going to have a load balancer, and every request from the clients is going to be redirected with one of the 3 available pods or replicas. Okay. So inside the containers part here is where you can actually configure everything. For example, I am using the image pool policy never because I have just built the image locally. I have it on my local Docker, and if you use never and you are using Kubernetes for Docker for Windows, it will get the image from your local system instead of trying to go to Docker Hub. And here is where the magic.
So you don't have to go to a store or anything first.
Exactly. Okay, you can do it locally. Okay. And here is where everything, where the magic is configured to work with ASP.NET health checks and Kubernetes. You can actually declare the liveness proof. Okay. The liveness proof can be executed with different mechanisms. One of these can be, for example, making an HTTP request, but you can actually execute a script, parameterize the script, and there are different approaches. But to work with ASP.NET health checks, we are going to make a GET request to the path self port 80 with the scheme HTTP, okay? And these 2 parameters are very, very, very important because you can suffer a lot if you don't configure them well, okay? Let's imagine that we start in Kubernetes our application, and Kubernetes called our liveness proof inside the self path. The liveness proofs is used by Kubernetes to report if the application health is not okay. And what Kubernetes does in this case is restarting and killing the container trying to recover the health. So if this delay is not enough for the application to be ready, Kubernetes will kill the container in loop. It will be killed, restarted again, the liveness proof will fail, it will be killed again, and so on. Okay? So with this initial delay is important to have in mind that you have to give your application, depending on your source code, more or less delay seconds. And the readiness proofs is totally different from the liveness proof. The liveness proof will actually kill the container and restart it, but the readiness proof is going to call our ready path, and the application might be alive and up and running, but one of the 3 services that we require for our application to work, these 3 services we simulated here, might not be ready. So that means that the application is up and running, but it cannot serve requests to the clients because they are probably not going to work. So what Kubernetes does in this case is just not redirecting the client request to that container that is failing, because as you can see, we're going to use a node port that is designed for development, but this kind of service is has load balancing as well. Okay? Yeah. You have any doubt, or you want to comment something funny?
No, I'm following like a bird. I'm watching you do things. It's very interesting. I did not know you have this liveness probe and readiness probe in Kubernetes.
Yeah, but you're gonna love it because with liveness and readiness probe, you sleep better at night. Okay.
And just the way it actually tries to sort of heals itself. You know, if
exactly.
Cool.
There are some scenarios where maybe your application is under heavy traffic and something can hang, or your application can be stuck, and Kubernetes will be in charge of all that things. Okay, so the first thing that we are going to do is apply a file that is the infrastructure file. Okay, and we are going to have a Redis and Wall SQL server. Okay, that are right now creating, and we have the 2 services exposing this on the cluster. If you remember, these are the names that we gave to the connection strings on the health checks, SQL Server and Redis, because as our web app containers are going to be running inside the cluster, they will see these services. Okay, and right now, here comes the more interesting part, that is deploying our deployment. And as you can see, we have right now one deployment that is called web app deploy, in which we have 3 replicas on our amazing web app application. And we have 3 up to date, and they are not available yet. We have 2 available now because the readiness proofs are being executed on that pods. Okay? Where the screen disappeared. Here they are. Everything is up and running, our Redis, our SQL Server, our web app deploy. And please see this last segment of the names, because it's the one that is going to allow us to see which one of the containers is answering us.
Yeah.
If you see the service of our web app, we are being offered a load balancer on the 30,000 port. And this 30,000 port is the port that is going to be redirecting the request to every one of these pods. So if we try to execute this middleware, this last one middleware that has no path, we're going to receive the hello from the containers. Let's try it. For example, curl http / localhost 300. We have received the hello from the container 6vjhg. If we do it again, we are being answered by another container. And if we are lucky, we will see the last one here. Okay? So the overall health of our pods right now is, hey, all of them are running and all of them are ready. This is the flag that is the output of the readiness proof. Okay? If our application can be running, but it can be 0/1, that means that SQL Server Redis or the other dependency is not ready, and that container won't receive traffic. So, for example, using our health checks that are configured, the self check, we are going to swap or to switch the app healthy by calling to the switch. And we don't know which one of the containers is going to die, but one of them is going to die without a doubt, okay? So we are going to call to the load balancer, and we're going to switch to false. And in this case, is the THVC4 container. Let's try to kill another one. We kill the 6VJ. And if we start looking the bots with the watch flag, we're going to see how very soon this THVC4 and 6VJ are going to be killed and restarted, and the restart count is going to be 2-1. Right now, they are dead. Okay, but Kubernetes is going to execute sooner than later our liveness check, and is going to see that our status code is not successful, and Kubernetes is going to say, hey, ASP.NET is reporting failure. Let's kill the container. Okay.
Yeah.
Let's see. This should be happening very fast. I don't know if I have an error on the image. Let me check that I put everything in place. APP healthy is different of APP healthy. This is taking too long, more than I expected. Maybe something is not great. Context, health check status change. This is very weird. Whoa. Why this aren't these getting restarted? Maybe you can help me to see if I have a bug. APP healthy was true.
Maybe just query that endpoints and see if it's really true.
Oh my God, here's the failure. Healthy and healthy.
Yeah.
Oh my God, this always happens when you're live coding. Okay, sorry for
Demo gods.
Exactly.
demo. Yeah, exactly. Okay, let me change it because our application was gonna be healthy all the time with this like that. Okay, I'm going to delete the to get sure that this is working. I'm going to delete the infrastructure.
You see, actually, before you continue, well, you can continue. This is actually a good use case for Roslyn. If Roslyn sees that you are returning true or true, then it should sort of underlying say, really, are you really sure you want to do this? Because you say if true, else true. No?
Yeah, actually, it would be very good, the Visual Studio, to help you not commit that error. Sorry, I am fast typing and I miss it. Okay, so we are going to build a Docker image again. Okay, Docker build/c. The name was web app. The context is this one, and our Docker file is this Docker file. And hopefully this is going to work right now. This is the part that I think is great from the health checks and Kubernetes. Everything is in place, and let me apply the deployment again.
Apply.
Oops. I am missing characters today. Okay.
Yeah.
Let the bots be ready. They are running, not ready yet because Kubernetes is calling SQL Server, Service Bus, and all that stuff in order to have a 1 here. So the load balancer won't be giving any response until one of them is healthy. One is healthy, two are healthy, and we can start messing with them. This is like the monkey chaos, you know, you are going to destroy things.
Yeah.
Let's call, for example, with curl again, localhost, switch, and the SQP2R is out of health. And right now the N2 and NK is out of health. So let's watch them. And as we fixed our nasty bug, this should be working right.
I just have a question. So what's the chances if you say switch and switch the second time? How do you know it won't switch the first one?
I don't know. It can perfectly happen because the load balancer can redirect me to the same place. Indeed, when I was preparing this demo, that happened to me. So we have to be sure to switch again some of them because it won't. Nothing will happen then. Okay, you can see
That goes on.
the ASPNETCore has been restarted, and this one has been restarted, and they are running the readiness proof, calling to our ready endpoint here. And the global health status is that thanks to the health checks, to the Liveness checks, we have recovered these 2 pods and they are up and running again. Okay.
Yeah.
What would happen if we make the chaos not against the switch but against the service? It was switch service, right? Yep. Okay. We are going to put one of the pods, in this case, one. Oh, the same. Your answer got through. The same. And this one. Okay, we have now 2 pods that are going to report that are not ready. They are healthy, but the simulated service bus is not working. All the other dependencies of service are working, but not the service bus. So we are going to have a trouble because we the container is running, but the load balancer isn't going to be redirecting requests to them. So the only container that is going to be answering is the one that is not SQP and M2N. As you can see, this one is not ready now, and this one is not ready now. If we see the overall health of the pods, crap, we only have 1, okay?
Mm-hmm.
Yeah.
If we call with curl to our hello endpoint, we are always gonna get the same answer from the same pod.
Yeah.
And if we finish destroying things, we can actually scale the Kubernetes deployment. We can say kubectl scale Redis. Okay, sorry, scale deployment Redis with 0 replicas, and that is gonna imply that all of our pods are gonna be down. One because of one of the real dependencies, in this case ready, is down, and the other 2 because we flagged that we changed this flag and they are not ready. Could you tell me, Fanny, if we are gonna be able to call again to the switch service on the containers?
It depends if it restarts, all right?
Yeah, if it restarts, but there is a problem. How the container is up and running? He's not dead. How can I reach the switch? How can I reach this switch?
Probably
switch
through
service. I can reach the service because the load balancer is not serving it to me.
Yes, I have no idea. Maybe access it directly.
Yeah, it's something like that. Okay, I'm going to call curl again, and as you can see, our service is going to say empty reply from server. You don't have anything ready. All the pods are alive, but the services are not working well, and you can get an answer. Okay, so let's scale again Redis to have one of the pods running. And what we can do, if we execute again this, okay, Twitch service, we are going to kill the last pod that is alive, because the other two pods are out of traffic. They are not getting redirected any of the requests. So I'm going to make a little trick. Okay, let's see. We have now one pod running. Okay, we're going to connect with an interactive console to, for example, this pod that is the SQP2R. You're going to grab the identificator, and we are going to execute a bin vas. Let's hide this. We're going to execute a bin vas against this container, and right now I'm inside the container. You can see our application here, and I'm going to execute a curl against the switch service fat inside. Okay, I have jumped the load balancer, and directly in the pod is the only way that I can restore this service again. And this pod has been changed to true, and we should have again 2 pods serving our request. This will be changed, no time. And it is ready now. If we call again to localhost, set K8 answers and SQP2R answers.
I see.
Yeah.
Okay, so this was the demo to show how you can actually play with this new feature from the ASP.NET Core. I really like it. I think it's very good for a lot of scenarios. But my favorite is the containerized applications with a container orchestrator.
That was quite cool, because the other thing you could have done is just restart the pod, right? Or
Yeah,
force
but
it.
yeah, I could have, exactly. This was a trick. Maybe I could have just ctl delete pod and delete it, and that flag that was indeed we can do it with this. This is no, we want the one that is dead. We have this one dead. Let's kill this pod. Ctl delete pod. Okay, this has been killed, and it is terminating right now, and soon it's going to be healthy. Yeah, that would be another approach, but I wanted to execute our switch.
Give you the effect, yeah.
Yeah. Okay, so this is very good because the liveness and readiness proofs are thought for different purposes, and they are very good when you're working with, for example, with AKS on Azure with your cluster and your containers. This can save you a lot of travel that would require human intervention or that kind of problems.
Wow, that was powerful. Thank you very much. Good demo.
I hope you enjoy it. Yeah,
It's incredible how fast time goes if you have some good coding on the show.
Exactly.
Thank
Do you have
you.
some of these demos available for us to put on the show notes somewhere on GitHub? We can.
Yeah, I can upload this demo if you want to GitHub, and I can publish it later.
Okay, maybe just do it in your own time, and then maybe give us a tweet or something, and then we'll add it to the show notes.
Okay, I will upload to my GitHub account, and I give you the link.
Brilliant. Thank you so much.
What will you be focusing on the next couple of weeks, months?
Me?
Yeah.
Well, this year I have been very involved with blockchain development. Indeed, there has been several times from even .NET groups or events where I have been requested giving this blockchain development talks. But I would like to focus on ASP.NET with Kubernetes. I'm trying to become a Kubernetes guru. We have a partner of in our enterprise that is called Eduardo Tomas, that he's very, very good with Kubernetes. And the other partners, we are learning a little step to step, you know. And I really like all the cloud stuff with in Azure with AKS, Kubernetes, and containers using .NET Core.
That's very cool.
Are you planning to go to the summit in March?
Yeah, definitely. We're going to Chicago first because we want to visit the city, and then we go to Seattle, and we will be there.
Well,
We're looking forward to see you there.
Yeah, we will meet finally there.
Absolutely.
Well, thanks for attending the show. And as I said, the time really flies if you have some good coding on the show. And next time we will be here, I think the 24th, next Tuesday, the Thursday again. And from what I heard is that Gerald has another guest that usually would be on the .NET South meetup, but that was cancelled, I think. So he will ask him to join us next week. So let's see what's coming from that. And see you next week. Then bye-bye.
Cheers.
Has been a pleasure, guys. See you.
Bye.
Bye.
If my endly de Warang.